A million miles from Earth, suspended in deep darkness near the Sun-Earth Lagrange point L2. The James Webb Space Telescope is doing something far more profound than simply observing distant objects. It is excavating cosmic history itself. Every photon it captures has traveled across unimaginable distances, some for more than 13 billion years, carrying fragments of the universe's earliest memory. Yet what those photons reveal is not the quiet, orderly beginning scientists once expected. Instead, they tell a story far more complex, far more accelerated, and far more mysterious. For decades, modern cosmology described the early universe as a gradual unfolding after the Big Bang. Matter spread into a vast, nearly uniform sea of hydrogen and helium. Tiny fluctuations in density acted as seeds. Gravity slowly amplified those seeds, drawing matter inward. Invisible halos of dark matter formed the scaffolding upon which galaxies would grow. Gas cooled, collapsed, and ignited into the first stars. Primitive galaxies slowly assembled. This process, according to theory, was expected to take time. Hundreds of millions of years for the first small galaxies. Billions more for large, structured systems. The early universe should have been dim, chaotic, unfinished. That was the expectation Webb was built to confirm. Instead, it found something far stranger. When Webb looked deeper than any telescope before it, it did not find a slow cosmic dawn. It found maturity. Within just 500 to 700 million years after the Big Bang, it detected galaxies that appeared shockingly massive. These were not tiny clusters of newborn stars. They were systems containing hundreds of millions, even billions of stars. Some seemed comparable to the Milky Way. That should not be possible. Galaxies are expected to grow step by step. Dark matter gathers. Gas falls inward. Stars ignite. Those stars create heavier elements and eventually die, enriching future generations. Each stage requires time. Yet Webb is observing galaxies that seem to have skipped ahead, appearing far more evolved than theory allows. Astronomers have even called some of them universe breakers. Not because they break physics, but because they push our models to their limits. It is as if scientists expected foundations, but instead found towering structures already complete. Naturally, skepticism followed. Maybe gravitational lensing made them appear brighter. Maybe dust distorted the data. Maybe distances were miscalculated. Some corrections reduced the extremes. But not enough. Too many massive galaxies remain. Far more than expected. And the pattern repeats. Again and again. This is no longer a few anomalies. It is a trend. And that changes everything. The question is no longer whether these galaxies exist. It is how they formed so quickly. And once that question appears, another follows. Because galaxies are only part of the puzzle. At their centers may lie something even harder to explain. Supermassive black holes. Objects millions or billions of times the mass of the Sun appearing astonishingly early in cosmic history. Under standard theory, this should not happen. Black holes form from collapsing stars and grow by pulling in matter. But that growth is limited by radiation pressure, described by the Eddington limit. Even under ideal conditions, reaching billions of solar masses should take far longer than the universe's age at that time. And yet, Webb suggests otherwise. Some early galaxies appeared to host enormous black holes just 100 to 200 million years after the Big Bang. At that stage, the first stars may barely have existed. The timeline does not fit. To explain this, scientists are exploring new ideas. Direct collapse black holes. Extremely massive first stars. Rapid mergers in a dense early universe. Even unfamiliar hybrid objects between galaxies and quasars. None are fully confirmed, but all point to the same conclusion. Something is missing. And the surprises continue. Because Webb is not only revealing unexpected objects, it is uncovering unexpected structure. On the largest scales, the universe forms a cosmic web. Filaments of matter stretching across millions of light years, connecting galaxies in vast networks. This structure was thought to form slowly. Yet Webb may be seeing signs it formed much earlier. Chains of galaxies. Dense clusters. Organized systems that seem too advanced for such an early time. Some contain dozens of galaxies already interacting. Some show galaxies that have already slowed or stopped forming stars. They did not just form early. They evolved early. The entire system appears accelerated. Galaxies forming too fast. Black holes growing too quickly. Structures organizing too soon. Even familiar shapes appearing ahead of schedule. The early universe does not look primitive. It looks active. Complex. Almost mature from the start. And that challenges the foundations of cosmology. If these observations hold, the implications could be profound. Not small adjustments, but major revisions.